Okay, good afternoon. So let us continue the lesson. So if you remember, I was talking about integrals, how to use integrals to calculate areas. And now we want to use integrals to calculate volumes. But here, what is the meaning of volume of revolution? So assume that you have a function and this is the graph of your function, and then between two numbers, vertical lines, a, x equals to a and x equals to b, you have one area here. Now imagine that you start rotating this area about the x-axis. It will definitely generate a solid object for you. And now we want to calculate the volume of that solid object. Yes? For example, I don't know, if you have one straight line, how can I show it somehow to you? For example, assume that this is the x-axis, and then this is a straight line, just horizontal. If I start rotating it, I hope that you agree with me, it makes a cylinder, yes? So that cylinder is a volume. Or I don't know, if you have something like this, and then you start rotating it, something like that, it will make a cone for you, yes? So that is, I don't know, drawing these things might be a little bit hard, but what I mean is that you start rotating this area about the x-axis. I will try to show you some demonstrations using GeoGebra. Something like that. So if I can draw it, yeah, something like this. So if you start rotating this area about the x-axis, it gives you a volume, and you are interested into calculating that volume. That volume turns out to be, if you want to see why, you can see my videos on YouTube, but what you need to know is the formula that he was given to you in the formula sheet. The volume of this object, yes, it's a three-dimensional object, turns out to be equal to pi, the famous pi number, multiplied by the integral of your function, whatever it is, but squared dx. It goes from a to b. Sorry. Okay, so you need to have this setup in mind, that if you have a curve above the x-axis, and then between two vertical lines, you have an area. You take that area and rotate it about the x-axis. You will generate a three-dimensional object, and then you can talk about the volume of that object. The volume of that object turns out to be V equals to this. Okay, any questions? Okay, but if you really want to understand why this is, of course, this is not probably being asked from you, but if you're interested to see why this is the case, I have made a video, so it's on YouTube, so you can just check it out. But what you need to do is to learn how to use this formula effectively. And there are nicer pictures, of course, in your book. If you want, you can follow them. So there are some examples in the book, but if you don't mind, let me start solving the problems in the book for you. Okay? So, this is book Exponent 4. And then I hope that the numbers in my hard copy matches with the one in the digital version. Yeah, but hopefully that this will be the same. But I will write the problem here. So this problem that I want to solve is problem 5080. Yes. And this is telling you that we want to calculate the volume. So they have actually drawn a picture here for you. Yes. So this is the picture. So you have this graph, and they have written on it y equals to square root of 2x, and then you rotate it about the x-axis between 0 and 4. So this point is 0, and this point is 4. You start rotating it about the x-axis. So what do you get? So this is the area. So you consider this area. And then you rotate this area about the x-axis. So hopefully you agree with me that this will generate something like that, yes? Something like this. And then you are supposed to find the volume of this object. Is that possible to visualize or not? Yes? Yeah, so something like this. And then you want to find the volume of that one. So it's very, very simple problem. Yes? You need to take this formula, V. You can take it from the formula sheet, of course, you don't need to memorize. Pi integral. Okay, so let us see. dx is always dx. But the lower limit and the upper limit, you see, I start from 0. According to the problem, I go up to 4. So the lower limit is 0. The limit above is 4. And then your function is a square root of 2x, but you have to raise it to power 2. So it becomes square root of 2x, and then you square it. Yes? So actually this is the new lesson. After that, this needs your skills in calculating integrals. So from now on, nothing is related to the graph. You need to concentrate on solving this integral. So what I do, I copy and paste pi, integral from 0 to 2, but instead of writing square root of 2x squared, I use these two to get rid of square root sign. It becomes 2x, and then I will have dx. And if you ask me what is a primitive function for this one, I would say pi is pi, 2 is 2, but a primitive function for x is x squared over 2. I have to run this from 0, oops, I made a mistake here, this is not 2, this is 4. I have to run from 0 to 4. But before doing that, you see that these 2 and that 2 are cancelled. So what I get is pi x squared. It goes from 0 to 4. So I have to replace x with 4. It becomes 16 pi. I have to replace x with 0. It becomes 0. And I have to write the number above minus the number below. So this becomes 16 pi. Whatever it is, I write volume units, because this integral is supposed to measure the volume. Yes? So that is the volume of this object. Any questions? Okay, let me solve the part B of this problem. So this was part A. And then 5080 part B. Now, this is given to you. And they have given you a line. They have written y equals to x over 2 plus 1. And then they have considered it from 1 up to 5. And this area is supposed to be rotated about the x-axis, and then you want to find the volume of the object generated. So, a question?
dx, how did you get it?
No, dx is always there. dx is, if you want to write an integral, dx is always there in an integral if you go back and watch the videos. When you write an integral, If you always put the x, meaning that x is the variable. This is always there in integral, denoting which variable it is. Okay, so if I want to solve that one, then first of all, let us imagine if I rotate this area above the x-axis, hopefully that you can agree with me that this will generate some circle like that, and then this is the same thing, but a little bit bigger, and then this will give you this. This is like a cone that you have cut the head, yes? So this object, you want to find its volume. Okay, but that is mainly the same problem. The only difference is that instead of function y equals to square root of 2x, I have another function here, and the limits, instead of going from 0 to 4, it's going from 1 to 5. So that's it. If I want to calculate the volume becomes pi integral. The lower limit in this case is 1. The upper limit is 5. And my function is x over 2 plus 1. But according to this formula, you have to write your function as squared. This becomes to the power of 2, and as usual, dx. Okay, so do you remember, if you want to find an integral, first you need to find a primitive function for your integrand, your function. But if I want to do that, I have to expand it to power 2. So then I copy and paste this pi part integral from 1 to 5. This is a quadratic term, so the first one squared becomes x squared. Let me write it 1 over 4x squared. And 2 times the first one, which is x, times the second one, which remains x, and then plus the second one squared. 1 to power 2 is 1, and then, as usual, dx. So you shouldn't bother about dx, but you have to write it down. Yes. Now we have to calculate this, but that is simple. Yes, if I ask you what is, so let me just copy and paste the pi part, and then a primitive function for x squared is x cubed divided by 3. And that 3 multiplies here, it becomes 1 over 12, x to the power of 3. A primitive function for x is 1 over 2x squared. So you know that I am using this formula. A primitive function for x to power a is 1 over a plus 1 x to power a plus 1. If this is my function, this will be my primitive function. And a primitive function for 1 is just x. And then I have to run it from the lower limit 1 to the upper limit 5. Yes? And then I have to put these numbers, calculate the values, and subtract them. Yes. So what I do, I separate it into 2 parts. I replace every appearance of x here. So I take these x's away and put 5. So this becomes pi. If I put 5 there, let us do it in our head. If I put 5 in the first one, 5 to power 3 is 125. 125, and I have 1 over 12. And the next one becomes 25 over 2, and the next one becomes 5. And if I want to simplify that, I write pi. The common denominator is 12. 12 to 12 1 times, so it is 125. 12 to 6 times, 6 times here is 150. 12 times 5 is 60. And then the final step is adding these numbers. So this becomes 185. So 335 over 12. Instead of writing pi here, I write pi here. Yes? And I do the same thing by putting 1, but 1 is very simple. When I put 1 here, 1 here, 1 here, all these numbers become 1, so I will have 1 over 12. Of course, I have also a pi here. This becomes 1 over 12. The next one becomes 1 over 2. And the last one is just simply 1. And if I take the common denominator again, 12 is the common denominator. So this is 1 times. This is 6 times. I multiply here. And this is 12 times, yes. Then it becomes 19 over 12 pi. Then I go back to horizontal line and I write the number above, whatever it is, minus the number below. Okay, but 335 minus 19 is how much? 316, yes. And then over 12 pi. Of course, it is clear that I can simplify by 4. So this becomes 3, 75, 79, yes. And this is volume units. So that is the number. I can also check the faucets so that I haven't made mistakes. Yes, 79 pi over 3. Any questions? Okay. Okay, some questions are like this. So the graph is given in the problem itself, so you see the volume in front of your eyes. But sometimes they express it in words, so you need to do some graphing yourself. You really don't need to be precise in drawing the graphs, because you need to motivate yourself, how should I continue? So for example, let me choose one of these problems. Okay, so problem, for example, 5084. I cannot translate it exactly, but I understand probably what's going on. So you have a region which is limited by these curves. The curves are given. So this is a word problem. You need to read and then find the answer. So you have a region which is limited by these curves. By the curve, not by curves, by the curve 0.5, y equals to 0.5 e to the power of x over 2. And the lines x equals to minus 1, x equals to 1. Okay? And the x-axis. So what does it mean? It means that you have a region. On the left-hand side, it is limited by this vertical line. On the right-hand side, it is limited by this vertical line. Below, it is limited by the x-axis. And above, it is limited by this curve. So it makes an area. You're supposed to rotate that area above the x-axis. Again, it will generate you a solid object. You are supposed to find the volume of that solid object. So essentially, that's the same problem, okay? Of course, if you want to understand it better, if you are allowed to use your calculator, might be that's a good idea to draw the graph to understand it better. Otherwise, you can just solve it using the formula that I gave you above. So if you do the graphing, so this is an exponential function. So here it is 0.5 and the graph of this function will be like this. I don't really want to be very precise. I just want to sketch something to understand the problem better. So that is the graph of this function. So you can use, for example, any graphical tool to make it plausible for you. But x equals to -1. Here, if that assume that here is -1 and this is my vertical line, x equals to -1. X equals to 1 is somewhere here, and that's also another vertical. And then you see that the region limited by these and that x-axis and this one. So that is what we are supposed to. And then we rotate this about the x-axis. Okay, so of course you really don't need, because what you need to just to calculate the volume, but if you want to imagine it, you can imagine it in this way. So it is not enough space here, but it goes like that, yes. So that volume. You're supposed to find that volume. But you really don't need, because what you need is the formula that I wrote there, and then you substitute what you have here. Okay, so what is the answer? The answer is the volume. Volume is pi integral. The lower limit, the left side limit is -1 because I am interested from -1 to 1. It goes from -1 to 1. But my function, not function itself. Do you remember for the area, you put the function itself there, but for the volume, you need to write a function and square it and then integrate. And of course, you have an extra pi. And the formula for the area, you didn't have any pi's there, yes? Okay, then what I have to do, I have to copy and paste that part first. But then I have to raise this to power 2. 0.5 to power 2 becomes 0.25. E to power x over 2 to power 2. If I have e to the power of x over 2 and I want to raise it to power 2, then this 2 will be multiplied by that. 2 times x over 2 is just simply e to the power of x. And then I have dx. Yeah, they're actually very, very simple. This is a constant. I can take it out, and then a primitive function for e to power x is e to power x itself. So that's probably one of the easiest problems, yes? So this becomes 0.25, and then you have a pi. A primitive function for e to power x is coincidentally the function itself. But you have to run it from -1 up to 1. It means that you put 1 instead of x first, which is, if you don't mind, instead of 0.25, let me write 1 over 4. So this becomes pi over 4e. And then you put -1 here, and then I will do the same thing here. So the answer becomes exactly pi over 4, this time e to power -1. And then you have to keep the values exact, so you really don't need to put anything in the calculator, unless it is mentioned in the problem itself that you need to do approximations. So I write the number above minus the number below. That's it. If you want to, of course, I don't know, depending, I can see the faucet. Might be they have changed it a little bit. I can factor a pi over 4. It's not necessary. If you stop here, that's okay. But I factor it out, it becomes 1e. Instead of e to power -1, I might be able to write 1 over e as well. But I told you, if you stop here, that's completely okay. So that becomes the volume of that. Yes, let me check the faucet. Might be they have written a different way, or they have used decimal points rather than fractions. But it doesn't matter at all. Okay, so that's problem 5084, yes? Yes, but they have written it exactly instead of 1 over e, they have written e to power minus 1. But that's it. Yes? Any questions? Okay, so now we go, let me solve at least 2 level 2 problems here. Any questions here? Okay, so we go to level 2 problems. It might be they are a little bit harder. So they are not hard actually. 50, 85. So the curve, again, you don't have the picture in front of you. So the curve y equals to 3x minus x squared together with the x-axis actually restricts a region. We take that region, rotate it about the x-axis, and we make a volume out of it. Again, find the volume. So here they have mentioned that if you take this curve together with the x-axis, you will see that you will have one region. Okay, so you see that in this problem, x minus 1 and 1 are directly given to you, so I would consider this a simple problem. Even if you don't draw the graph, you really don't need to. You just take the function, the lower limit, the upper limit, and put them in the formula and you get, yes? But here, the lower limit and the upper limit is not given directly to you. So somehow, if you have calculator available to draw the graph, it's not bad. Otherwise, you can guess it, by the way, it's not hard, because that's a quadratic equation, so that's a parabola, yes? And then because this x squared is negative, you know that this parabola should be upside down. And then let us find the roots, the zeros. So what are the zeros? If 3x minus x squared, I put it equal to 0, then I factor x out. So this means that there are 2 roots here. One of them is 0, the other one is 3. So this means that at these 2 numbers, the y value is 0. So these are the intersection points with the x-axis. So one of them is here, the other one is, for example, here, 3. And this is a function, this is a parabola. So I don't really need to be very precise, but I just want to understand what is going on. And then this is my curve now. Yes? So then it means that they were talking about this region, because they mentioned this curve and the x-axis actually make a region, and then you want to rotate that region about the x-axis, you are supposed to find its volume. Yes? So what happens here? So it means that if I rotate this, yeah, hopefully you agree with me, you will get something like that. So you want to find this volume actually. What happens if I start rotating? But now you understand the problem is exactly as before. And now if I ask you what are the lower and upper limits, you would say that the lower limit of this region is 0, the upper limit is 3. So these numbers you got it yourself. And then you put them in the formula, yes? Okay, let me start here. So this becomes v equals to pi. I'm using the formula above here. And then integral. Now I understand the limits are 0 to 3. And then be careful. Do not just put the function itself. You have to square your function. Yes? Okay, so we have to calculate that integral. we are supposed to calculate this, but I have to square it. So the first one squared, 2 times the first one times the second one squared. So this becomes equal to pi integral from 0 to 3. The first one squared is 9x squared. 2 times the first one becomes 6x, and I multiplied by negative x squared, so it becomes minus 6x cubed. And then the second one squared is x to the 4. And then I have dx. But these are very, very simple functions. A primitive function for x squared is x cubed divided by 3. That 3 that I divide will cancel part of it, it becomes 3. So let me just write it. It becomes pi, and then this becomes 3x cubed, yes? Because a primitive function for this part is 1/3 x cubed. 9 divided by 3 becomes 9. A primitive function for this one is 1/4 x to the power of 4. But 6 divided by 4 can be simplified, and I can write it as 3/2 x to the 4. And finally, this is 1/5 x to the 5. And I have to run it from 0 to 3. Here, fortunately, we do not need to bother about the lower limit, because if I replace x everywhere with 0, I will get 0. So the only thing matters is the number above. So there is no subtraction involved, because that is subtraction by 0. So this becomes pi. I have to put 3 here. So let us do it in our head. So if I put 3 here, 3 to power 3 is 27. Multiplied by 3 becomes 81. Yes? I put this here. 3 to power 4 is 81. Multiplied by 3 is 243. Divided by 2. Okay, and then if I put 3 here, 3 to power 5 is 243 divided by 5. That's it. So for example, you can take the common denominator here. The common denominator between 2 and 5 and 1 is 10. 10 multiplied here is 810. 10 divided by this 5 times. If I multiply 5 here, 1200, and then that's 15, yes? Yes? And then 2 times here, if I multiply that, it becomes 486. And then you need to add these numbers and subtract them. Let us see how it works. This is 1200, that is gone, minus 581, yes? This becomes 81 over 10 pi volume units. Let me double check. So you see that was a level 2 problem, but I don't think it was hard. The only thing probably considered level 2 problem, you need to find the limits yourself. 0 and 3 was not given directly in the problem. Yeah, the answer is correct. 81 pi over 10. Okay, I will solve 2 more, and then, of course, I did most of the part. Yeah, I will solve 2 more and then you can solve the rest of it yourself. There are 4 or 5 more left. So, any questions here? The next problem, I think, the problem 5087 is also good. The region which is bounded by this curve, the region which is bounded by this curve, square root of 5x plus a, and the y-axis, okay, so that's probably a little bit harder problem. The y-axis rotates about the x-axis. So this formula only works if you rotate your region about the x-axis, okay? So that's not hard, so they want to still rotate about the x-axis. Determine a positive value for a is positive, and you want to find it such that the volume becomes 8 pi volume units. Yeah, so that's a little bit different problem. So far, they gave you the function and they ask you to find the volume after being rotated about the x-axis. But here, they have given you the function partially, meaning that a is still missing. You want to fine-tune this a so that if you do that rotation about the x-axis, the generated volume is 8 pi. But their area is the one between this curve, not with the x-axis. According to the book, it is with the y-axis. So, in these kinds of problems, it is a good idea to understand what is going on about the curve. So what I want you to understand is to try to draw the graph. A is positive, so you need to have a good understanding of the curve. Otherwise, you might get some trouble. So here, this is it. So I don't know how, so you need to know a little bit about the curve of square root of x. So if I want to draw the curve of square root of x, if I put x equals to 0, I get 0. If I put, for example, 4, I get 2. If I put 4 here, and that's another point. So this is the curve of the square root of x. Of course, this is not square root of x, it is a square root of 5x. Square root of 5x, the form of the function is the same, yes? But of course, it becomes a little bit higher because of multiplication by 5. But then the point is that what will happen if I have this number a here? We have already studied that. So square root of 5x plus a can be viewed as a square root of 5x plus a over 5. So do you remember this number which is added to the x? We had it in chapter 2. That reminds you of a shift about the x-axis. Sorry, in direction along the x-axis. But because a over 5 is positive, so this shift is towards the left. So this means that you have to take this curve and shift it a over 5 units to the left. Okay, so for example, if that is a over 5, minus a over 5, I shift it to the left, so that would be my graph. So somehow, because by the way, this is a little bit hard problem, because even if you have calculator, you cannot do that, because the calculator needs this number. What you can do, you can randomly put a number there, positive number there in your calculator, and ask your calculator to draw. The calculator, of course, will not draw exactly this, but it becomes very similar to this. So that is the trick. Unless, otherwise, you have to convince yourself. And so starting from square root of x, which is this one, I multiplied by 5, it becomes a little bit higher because I multiply. And then you see that by this trick, I understand that x is added, a over 5 is added to x, and we had in chapter 2, if you remember, when I add something to x, the effect will be shifting the graph along the x-axis. But because I am adding something positive, the shift is going to the left. It was the other way around, if you remember. So somehow, something like that. And now, let me read the problem again. So this curve, okay, the area, the region bounded by this curve and the y-axis. Okay, I think they should also have mentioned the x-axis as well, yes? But they have mentioned the area between this curve and the y-axis. Of course, they mean this. Yes? This area is rotated about the x-axis. And then the object generated like that has volume according to this problem, 8 pi volume unit. We want to find this 8. But the problem is exactly the same. But you should write that volume is equal to the integral, of course, a pi here. The lower limit is this number, minus a over 5. The upper limit is 0. And then your function is this, but you have to square it. Yes? But this volume in this problem is given. It's 8 pi. So instead of volume, I put 8 pi equals to, instead of pi, I just put pi. And then I square this one. This becomes minus a over 5 up to 0. And then I square it. It becomes 5x plus a. And then I have dx. Questions so far? Okay, so the only thing that is missing in this problem is just this a, and I have to calculate. But before doing that, I divide everything by pi to get rid of this pi. So what is left on the left is 8. On the right-hand side, I have to calculate this integral. A primitive function for 5x is 5 over 2x squared. A primitive function for this constant is just ax, and then I have to run it from this number to that number. Okay, so I copy and paste 8 once more. What I have to do, I have to break it into 2 parts. I replace x with 0, but hopefully you see that when I put 0 here, I 0 here, the answer totally becomes 0. But then I will take this one and put it here. So I will have 5 over 2. Instead of x, I put this number squared. It becomes a squared divided by 25. I put it here. A times minus a over 5 becomes minus a squared over 5. And let me simplify that. This 5 and that 25 are simplified. So this a squared over 10 minus a squared over 5. Let me continue by taking the common denominator. This becomes a squared, but 10 divided by 5 2 times, so it becomes minus 2a squared. A squared minus 2a squared is minus a squared, and then over 10. Okay, then 8. Then I have to go back to horizontal, of course. The number above minus the number below. One more step. 8 equals to minus turns out to be positive a squared divided by 10. So this means that a squared is 80. Yes? And then it means that a is plus or minus the square root of 80. but they have mentioned in the problem itself that a is positive, so I only take the positive one. So this means that since a is given to be positive, a becomes the square root of 80. Square root of 80 can also be written as a square root of 16 times 5, because 16 times 5 is 80, but the point is the square root of 16 is a nicer number, it's 4. So then it means that a is equal to 4 times the square root of 5. So if I haven't done something wrong, that would be the answer to this problem. Okay. Yeah, so please see if there's any questions until I check the answer. Yes, 4 square root of 5. So the answer is correct. So I would consider this is the only hard problem so far. The previous problems is just putting the function into the formula. Yes, is that understandable? So this is a little bit indirect problem, because in all the problems, they give you the function, they ask you to calculate the volume. Here they have given you the volume, you are supposed to find your function somehow. That is a little bit indirect problem. I will solve one more and then I stop. If you want, you can practice, and if you have questions, I will answer them. So let us solve problem 5088 as well. Okay, 5088. So Rif, I see that you have written something on chat. Unfortunately, I don't see it. Okay. So problem 5088. This is also probably a little bit hard. I don't know if I'm right. Yeah. So a function is given. The function is trigonometric function. Y equals to 0.5 cosine x plus 1. And then you rotate this function on the interval 0 to pi above the x-axis. And then you are supposed to find the volume as before. Okay, so again, if you really want to understand it better, it's better to have a sketch of your graph. If you have your calculator available and you're allowed to use the calculator in that part of the exam, I would recommend you to draw the graph. Otherwise, in principle, you should be able to do that, because cosine x is a famous function, yes? What is cosine x? So cosine x, so this is pi over 2, this is pi, this is 3 pi over 2, and that is 2 pi on this interval. I'm just considering cosine first, not 0.5 plus 1. Cosine x is, here is 1, so the function goes down, and pi over 2 becomes 0, and pi becomes negative 1, and then it goes back here, up to here, and it returns back to 1. Yes, that is the cosine function. But now you multiply it by 0.5. Do you remember? This is what is the effect of multiplying your function by 0.5? 0.5 is smaller than 1. The function is squeezed by a factor of half. Yes. So the function becomes, instead of going from 1, it goes from 0.5 This becomes negative 0.5. I'm squeezing the function. Something like that. So this is the graph of 0.5 cosine x. And finally, I shifted 1 unit up. Yes? So what happens? I have to shift this one unit up. It becomes 1.5 here. So this will be shifted 1 unit up. It will be here. This will be, oh sorry. Yes, that's correct. As this will go here. This will go here. This will go here. This will go here. And this will go here. So the graph will be like this. So the blue one is shifted 1 unit up. So this is exactly 0.5 cosine x plus 1. Okay, so I don't have more colors. Then between 0 and 2 pi, so let me just draw something like that. So this is 0, this is 2 pi, and this is the area. Yes? So it is not hard to guess what will happen, yes? It will be like a dumbbell, yes? When you, similar to a dumbbell if you rotate it, yes? If you rotate it, this part becomes fatter, this one becomes fatter, this one thinner. This is like a dumbbell, something like that, yes? Something like this, if you rotate it. And you are supposed to find the volume of that dumbbell shape or whatever you want to call it. You can call it, I don't know, a base. A base that like that. I don't know, whatever you like it. You can call it. But then we want to find the volume of that object. And then one thing becomes clear. You really didn't need to bother about graphing at all. Yes, because this was so standard that even if you don't know what you are doing, this will work. Because the limits are given to you. So what you do is actually volume is equals to pi integral from 0 to 2 pi. So you really don't need to draw anything. If you have calculator available, I recommend you to draw to see what's going on. But otherwise, you take your function and square it. And then calculate. Yes? So I mean that even if you just start using the formula for the volume and write this turns out to be correct. Yes? But this is a hard problem because calculating the integral turns out to be harder. So I want to teach you how to calculate this integral. Yes? So the first thing is that I will have to square it. So this will become pi integral from 0 to 2 pi. And then I square this one. The first one squared becomes 0.25 cosine squared x. But 2 times the first one, which is cosine x, multiplied by the second one, which becomes cosine x again, and then plus 1. The reason that this becomes a little bit harder is because you don't have any problems in principle with finding a primitive function for this. No problems here, but cosine squared, I want to teach you what to do. If you have cosine squared and you want to find the primitive function, you need to remind yourself about the double angle formulas for cosine. So if you refer to the formula sheet, you will see that there are 3 formulas for cosine of the double angle formula. One of them will be helpful for calculating this one. I will write the one which is useful. So one formula is this. If you refer to the formula sheet, this is one of the formulas provided for you in the formula sheet for the double angle, cosine of the double angle. And then I move this -1 from the right to the left. It becomes +1. Then I will have plus cosine 2x. And then you see that I have 2 cosine squared x. But I divide everything by 2. This one becomes 1/2. This becomes 1/2 cosine 2x. And the right-hand side becomes cosine squared x. So this formula in this form is not in the table, but you need to remind yourself that you have to use this, manipulate it a little bit, to reach to this formula. And then instead of cosine squared here, you just plug this expression in. And if you don't mind, let me write 0. Instead of this, I can write 1/4. Working with fractions is easier now. So then it becomes pi integral from 0 to 2 pi. I have 1/4. But instead of cosine squared, as I mentioned, I write 1/2 plus 1/2 cosine 2x. And then I have cosine x. And then I have this 1 here, yes? Now I have to simplify this a little bit. So this becomes pi integral from 0 to 2 pi. I multiply 1/4 inside. 1/4, 1/2 multiplied together, 1/8. The same here, plus 1/8 cosine 2x. And then I have a cosine x, and I have 1. But look, let me just add this 1 here to this 1/8 here. 1 is 8/8. When I add it to 1/8, it becomes 9/8. So if you don't mind, since I feel a little bit lazy, let me just clean it and write here 9/8. Yes? So 1/4 times 1/2. 1/8 plus 1 becomes 9/8. But let me remind you, do you remember the formula for primitive function for cosine? If you have if you have cosine kx, a primitive function for this is 1/k sine kx. So I want to use this, which is again in the formula sheet. That's the integral table. So what I have to do, I have to copy and paste this pi. 9/8, the primitive function becomes 9/8, a constant multiplied by x. But here, I want to use this formula. 2 here is playing the role of that k. So it becomes 1/2, but there is also 1/8 here. So you multiply them, it becomes 1/16. And then this becomes sine 2x. And what about cosine? Cosine x, you can compare it here, but 1, which is here, which is not written, cosine x means cosine 1x, k is 1, so 1/1 is just 1, sine of 1x, which is sine x, that's it. And then I have to run this from 0 to 2 pi. Okay, so what I have to do, I have to replace every x with 2 pi, replace every x with 0, calculate these numbers, subtract them. But the good news is that this is very simple. First of all, I don't need to be worried about the lower limit, because if I put 0 here, it becomes 0. If I put 0 here, sine of 0 is 0. If I put here, sine of 0 is 0. So when I put 0, everything vanishes. Yes? So what I put 2 pi here. So what happens? So this becomes pi. If I put 2 pi here, multiplied by that, it becomes 18 pi over 8. But the good news is that when I put 2 pi here, sine of 4 pi is 0, sine of 2 pi is 0, so nothing. That's it. And then this pi multiplied by that pi will give me pi squared. 18 and 8 can be simplified by 2, so it becomes 9 over 4 volume units. Yes? Okay, so let me check this one. Hopefully the answer is correct. And then I stop here. So that was problem 5088. Yes, 9 pi squared over 4. Okay, so I will stop here and I will update the Google Classroom in case you want to work on the problems yourself. If you have any questions, please let me know. Thank you.